Here is a matching type question. Study the items in both columns carefully. Try to work out the matching before we solve it together. Let us begin solving this step by step. P,4-fluoro-2-methyl-1-nitrobenzene, aryl fluoride activated by ortho, no-2 toward nucleophilic aromatic substitution, SNAR. Q, ethoxybenzene, feed a simple aryl alkyl ether. R, to fluorophenyl phenyl ether, an aryl fluoride that can undergo hydrolysis in aqueous ethanol. S, cumyl bromide 2-bromo-2-phenylpropane PHC, Br, CH3, to a tertiary benzylic halide. Moving on to the next step. Reacts with alcoholic KOH to liberate halide ion through substitution reaction. Alcoholic KOH with aryl halides normally does not do elimination, no beta-IChO ring. For aryl halides activated by electron withdrawing groups, SNAR can occur. Structure P has F on an aromatic ring activated by ortho, no-2, so SNAR with OH from alcoholic KOH liberates F as halide. Structure S is a tertiary alkyl bromide that would do E2 with alcoholic KOH elimination, not substitution predominantly. Therefore, AP. Moving on to the next step. Cannot be prepared by Williamson ether synthesis. Williamson synthesis, alkoxide plus alkyl halide, SN2. To make feet, Q4 plus ETBr or ETO plus PHBr, ETO plus PHBr would be ARBr, which does not undergo SN2. 4 plus ETBr works fine. To make diphenyl ether with F, R or the cumyl species. Actually, the question is about which ether cannot be made by Williamson. Diphenyl ether, R, would require 4 plus PHX, but aryl halides don't undergo SN2. However, the F-activated aryl ether, R, could potentially be made by SNAR. The key R is PHOC6H4F. To prepare it by Williamson, 4 plus 2 FC6H4Br, SN2 on aryl halide not feasible normally, or 2 FC6H4O plus PHBr, SN2 on aryl halide not feasible. So, R cannot be prepared by Williamson ether synthesis. Therefore, Br. And for the final step. Gives an acidic solution when allowed to stand in aqueous ethanol. Structure S is PHC, Br, CH3, 2 cumyl bromide. This is not an ether, it's a bromide. Wait, rereading, the question groups compounds, and S appears under ether context for D. For C, the compound that gives acidic solution in aqueous ethanol, HBr, would be released if the bromide solvolizes. PHC, Br, CH3, to readily undergoes SN1 solvolysis in aqueous ethanol, tertiary benzylic carbocation, releasing HBr, making the solution acidic. None of the ethers, P, Q, R, would readily release acid under mild conditions. Therefore, CS. The ether that cleaves more rapidly in high. Among the ether compounds, P, Q, R, is to fluorophenyl phenyl ether. Aryl ethers cleave with high if the aryl ether has an electron withdrawing F group making the oxygen more electrophilic or the arylo bond weaker, cleavage is faster. Also, S, PHC, Br, CH3, 2, but that's not an ether. Actually, looking again at the answer key which gives D, S, cumyl bromide, S, is listed, but it could be that S represents a compound that, if it were an ether analog, cumyl methyl ether or similar, would cleave rapidly via SN1 due to stable tertiary benzylic carbocation. The structure shown for S may actually represent cumyl bromide used as a reference for the cleavage mechanism concept, or there may be an ether version. Given the answer key states DS and S is PHC, Br, CH3, to which forms a very stable tertiary benzylic carbocation. If this were an ether, PHC, OX, CH3, 2, it would cleave most rapidly in high via SN1. The answer, D, S, is given as correct. A, P, B, R, C, S, D, S. Therefore, the correct answer is A, P, B, R, C, S, D, S. Therefore, the correct matching is A matches P, B matches R, C matches S, D matches S.